Well, all right, welcome to our next section, which, as you can see here, of course, is on conversion, obversion, and contraposition. These are, we could say, tricks you could perform with standard form categorical propositions. And while, at times in this section, it might seem like there's not really any point to this, I would motivate this section by looking at the example here at the top of this slide, right, which says, here's a sentence, some unregistered people are not people ineligible for financial aid, right? And of course, your reaction to that, I think, would be, what? What's being said there? It's a confusing statement. Well, the good news is, in this section, we will learn how to turn that statement into one that means the same thing, but is logically equivalent, we would say then, right, in terms of this class, but makes a lot more sense. In other words, that statement is logically equivalent to some people eligible for financial aid are not registered people. And, it's still a complicated statement, but I think that's one we can wrap our minds around, whereas the initial statement there is very confusing. So, as I say here, right, we're going to learn ways in this section to turn sentences like this one into ones that make sense, but also, of course, because these techniques will kind of work both ways, we will often be turning good sentences into stylistically bad ones, right? So, in terms of doing the exercises in this section, it's not like we're consistently, quote unquote, improving the sentences. But what we will be doing, certainly is, as it says here, performing conversion, obversion, and contraposition, these operations on the sentences. And so I'll talk to you about how to perform these operations here. In this video, we'll just focus on the first one, conversion. And then in the next video, we'll look at obversion and contraposition. But once we do that, we'll also be able to use Venn diagrams to understand whether or not the information in this initial statement is the same as in the converted statement, to just take that first example, or not. Okay, so we'll go ahead and look at that here in the next screen. And so here, it's a very simple procedure to convert a standard form categorical proposition. As it says, you just simply switch the subject and predicate terms, and that's it. There's nothing fancy about this, nothing tricky about it. So on the exam, right, exam 1, you'll be asked to take a standard form categorical proposition and convert it, right? Perform the operation of conversion on it. And all you're going to have to do is flip the subject and predicate terms. And so here, right, we see some doctors are not talented individuals, right? And then to convert that statement, we end up with some talented individuals are not doctors. So we just flip the subject and predicate terms. We see the same thing here in the next two examples. No frogs are mammals. Converted becomes no mammals are frogs, right? So hopefully the operation itself is very, easy to do. But what we want to also do is be able to draw the Venn diagrams for all of the claims here that we're looking at. And we will get to this last part here when we're talking about A and O statements not being logically equivalent when they are converted, and E and I statements, they actually are logically equivalent when converted, but we'll see that for ourselves, at least in these examples here. So what I want to do here is just begin by taking this first claim and doing a Venn diagram for it, right? And so we have some doctors, so we're going to have D for doctors, and then the predicate term is talented individuals, so I'll write T for that. And some means there is at least one, and so we know when we have the quantifier some, to diagram that with a Venn diagram, we're going to use the X. That X is a doctor, but it's not a talented individual, so the X would go over there. So we know how to diagram that initial statement. It's always going to be, once you perform the operation on the statement, that the diagramming will be a little bit more challenging, but we will certainly get through it here. So we'll look next at some talented individuals are not doctors. Now, as I said in previous videos, it's really important that you label your Venn diagrams exactly the same way from one to the next. So we're going to go doctors on the left, talented individuals on the right, even though, of course, as we see here, in accordance with conversion, the talented individuals is the subject term of the new statement, and doctors is the predicate term. But we want to compare them to see if they're saying the same thing or not, and to do that, you have to have the same labeling from one Venn diagram to the next. So we have some in the second statement, so we have an X, That X is a talented individual, but it's not a doctor, so it's got to go there, right? It's in the talented individual circle, but it's outside the doctor's circle. So what we can see right here then, of course, is that these pictures don't match. And the initial statement there, of course, is an O statement. And as we see here in this line, A and O statements are not logically equivalent when converted. And we can just see that for ourselves right here in these Venn diagrams. All right. So another way to put that is, if this first statement was a premise and the second one was a conclusion, this would be an invalid argument. But in terms of what I'm going to ask you to think about or do on the exam for this, is just tell me if the statements are logically equivalent or not, and you'll use Venn diagrams to show if they're logically equivalent or not. All right, so that's the first example. I'll just clean this up a bit here, and then we will look at the second two as well. All right. Okay, and so we have, in this next example, no frogs are mammals. So we have a Venn diagram. Of course, we're talking about frogs as the subject term and mammals as the predicate term. And so no is the quantifier. No means we're going to shade in. And so we need to shade where the frogs and the mammals overlap. So I'll just say, of all the quantifiers, I think the quantifier no is the easiest, because you simply have to identify where the subject and predicate terms overlap. Wherever that may be. In this case, obviously, it's in the middle here, and then you shade it in. So that's no frogs or mammals, right? It says there's no such thing. There's both a frog and a mammal. Okay, likewise, we will do no mammals or frogs. Now, again, don't do these too quickly and just write M on the left and F on the right. Again, the labeling has to be the same. So we're talking about frogs on the left, mammals on the right. And so now we're going to diagram no mammals or frogs here. Again, the quantifier is no, so we're going to shade. We're going to shade where the mammals and the frogs overlap. Well, as it turns out, that's the same area here as we saw in the previous example. And so what we would say then is that these statements are logically equivalent, right? They mean the same thing. That's what the pictures tell us. And so as we saw here in this last line, E statements and I statements, and you can do I statements for yourself just to see this, they are logically equivalent when they are converted, right? So that's what we've learned here about conversion, how to do it, and then also why they're logically equivalent in some cases and not logically equivalent in other cases by using Venn diagrams, and all of that you'll be needing to do on the exam 1.